Hello everybody. Today we'll be solving some questions from your daily quiz that was asked in the first week of July, okay, for engineering mathematics subject, obviously. Let's get started. This is the first question, and before we solve this question, this is a Laplace transform topic question, but this is a very common trick that usually the examiners in various competitive exams use, that they will make the question quite lengthy or scary looking, so that those who don't know or don't who haven't studied this Laplace transform topic, they will get scared and leave this question. Okay, but it's one of the easier question, I would say, from this topic. Okay, so what they have given you is a second order linear ODE. Okay, and it's a non-homogeneous ODE because RHS is f of t, and some conditions are also given. Initial conditions: y is 2 at t equal to 0, and dy by dt is 1 at t equal to 0. Okay, and they have given you that for small y of t, the Laplace transform is capital Y of s, and similarly for small f of t, it is capital F of s. Okay, so we usually don't write this full integral every time. You might have seen in our regular classes. So what we basically do is we basically write this as Laplace transform of y of t as capital Y of s, and Laplace transform of small f of t as capital F of s. Okay, so this is, they could have just said that capital Y and capital F are Laplace transforms of small f and small y respectively. But just to scare students, they do these kind of tricks. Okay, nonetheless, what they are essentially asking is for this ODE, what is capital Y of s? Okay, so let's go to the next slide and solve this, because it's a straightforward question. So given ODE is y double dash plus 4y plus 6. Okay, so what we have is y double dash plus 4y dash plus 6y is equal to sum f of t, comma y 0 is 2. So this is small y, and y dash of 0 is 1. Okay, so y dash means first derivative, double dash means second derivative. Okay, so this is our given setup. And what you can do, you can take Laplace transform on both the sides of this ODE. LT stands for Laplace transform. Both sides of, let's call it equation 1. So both sides of equation 1. And Laplace transform is a linear operator. So it will, multiply with each and every term. We can take the constants outside. Okay, this will be Laplace transform of f of t. Okay. Now, this will be capital F of s. Okay, this is capital Y of s, and there are some standard results or standard properties for the Laplace transform of derivatives. Okay, we have seen that in our regular classes. So this is written as s square into capital Y of s minus s into small y of 0 minus y dash of 0. Okay, so that will be nothing but s square y. I'm not writing y of s everywhere. Okay, and y of 0 is 2, so this will become 2s, and y dash of 0 is 1, so this will become minus 1. And this term, it will be Laplace transform of y dash. Okay, so that will be s into capital Y minus y of 0. Okay, these are standard formulas. Y of 0 is 2. Okay, so we have to plug everything up here. So then what it becomes is s square minus y minus 2s minus 1, y minus 2s minus 1 plus 4 into this sy minus 2 plus 6 into capital Y will be equal to capital S. I am not writing S every, okay, capital F, not F of S everywhere. And you are supposed to further simplify this. Okay, So what you do, you take the capital Y terms on one side from the LHS, and the remaining term you can put it on the RHS. So that will be S square is already there with Y, and there will be 4S also, and plus 6. So this will be multiplied by capital Y, and then this will be F plus 2S plus 1. Okay, so this term is I am taking on the RHS, and minus 8 will also be there, so that will be plus 8 here. Okay, and therefore you can write, so this is last step, so I'll write Y of S. So this will be F of S plus 2S plus 9, 8 plus 1 is 9, divided by S square plus 4S plus 6. Okay, so if you look at the options, okay, so I think option B is the correct one, right? That's what we have gotten. Yeah, and your answer also is the same thing. Okay, so this is one of those lengthy, scary looking questions, but if you really look at this is one of the easier questions from this Laplace transform. Okay, because they are usually, you're supposed to solve for this further to get small y of t in terms of f of s. Okay, so that is the question. Okay, so many times don't just get scared by the length of the question or the manner in which it is written. Okay, just read it and solve it easily. Okay, so let's go to the next question. So there are three faces of a fair die. Okay, that are yellow, two faces red, one face is blue. Okay, so there are 6 faces. Okay, in a die there are total 6 faces of a die. Okay, and it's a fair die, so the probability of each face is 1 by 6. Turning up is 1 by 6. 3 of them are yellow. Okay, 2 are red, and 1 is blue. So Y, R, and B represents yellow, red, and blue. Okay, so short form. Die is tossed 3 times. Okay, the probability that colors yellow, red, blue appear in the first, second, third tosses respectively is. Okay, so this is one way of asking this question, in which they are saying that at each trial or each toss, different color should appear. The same color should not appear. Okay. So if you do that, let's see. Okay, so okay, so there are three tries, right? 3 tosses that you do. So now, what they are asking is, in the first try, yellow appears in the first toss. Okay, so that means in the first try, yellow has to appear. So that means, yellow has to appear. So what is the probability of yellow faces turning up? So there are 3 yellow faces out of 6. So that will be 3 by 6. Okay. And in the second trial, they want red. Okay, so that probability will be 2 by 6 because there are 2 faces of red color. And the last trial they want blue. Okay, so that will be 1 by 6. Okay. And this is a very interesting question. Okay, see, if they have asked you that in these 3 trials, one has to be yellow, one has to be red, and one has to be blue, then in that case, yellow can appear on the first trial, second, or third. So in that case, you need to multiply by, this fraction by 3. But here they have specifically told you that, first is yellow, second is red, and third is blue. So in that case, this is the only case that is possible. Okay. But I have seen in many times the GATE exam, no, they don't mention that first has to be yellow, second has to be red, and third has to be blue. They will just say one has to be yellow, one has to be red, one has to be blue, or even going further, they will just say all 3 trials should have different colored face turning up. Okay, so in that case, you have to multiply by 3 here in this answer, but here it is not required. So since this is multiplication rule of probability. So one event and then second, and then the total probability will be the multiplication of all those individual event probabilities. Okay, so this will be 6 by 6 into 6 into 6. Okay, so that will be 1 by 6 into 6, 36. And if you do that, it will be 0.0278. Okay, and that is also within your range. So in this probability type of questions, I tell you, the only thing is, to understand the question, what they're asking. That is the most important thing. If you understand that much, then the rest of it is more or less straightforward. But many times students don't answer or don't understand correctly what the question is asked. Okay. So yeah, this is also one of those questions. Looks scary, but if you understood it, you could have solved it easily. Okay. So let's move on to the next question. Okay. So they have given you a vector field which is xi cap, yj cap plus zk cap, 3D vector field. And the vector field is, so they are talking about divergence and curl. Okay. And the divergence free means this, or maybe we can go to the next slide. So because they are talking in these terms, no, divergence free, curl free. So divergence free basically implies the divergence of this vector field. Let's call this as f, okay, xi cap plus yj cap plus zk cap, right? So divergence free means if you take the divergence of this, it will be 0. Okay, and curl free implies if you take curl of this vector field, it will turn out to be 0. So this is what they are basically asking. Sometimes students get confused in these terminologies. What is divergence free, what is curl free, and all these things. And that is deliberately done also to confuse students. But if you know these terms and if you understand the basics of that concept, you should be able to answer this question with ease. Okay, we have discussed this many times in our regular classes. So first talk about divergence. Okay, so that will be nothing but del f by del x plus del f by del y plus del f by del z. Okay, that is your divergence. So here if you do that, okay, and it is f1, f2, f3, not the whole thing. So basically, f1 is x, f2 is y, and f3 is z. So f1, f2, f3 are x, y, z components of your f, and they are x, y, z respectively in this question. Okay, and because this divergence is defined in such a fashion that you take the component-wise gradient in that particular direction and then sum it up. So divergence for a vector field is always a scalar. Okay. So here del x by del x will be, so this will be del x by del x, this will be del y by del y, this will be del z by del z. So all this will be 1 plus 1 plus 1, 3. So this is not equal to 0. Okay. So therefore, f, your vector field, is not divergence free. That is first thing. And divergence free, so this option is not correct. This option is also not correct. So answer will be amongst B and D. Okay. So let's talk about the curl. Curl of your vector field f. So curl also has a standard formula for a 3D vector field. Okay. Del by del x, del by del y, del by del z, and then your f1, f2, f3, the components of your vector field in x, y, z directions. Okay, so that will be x, y, and z here. And you are supposed to evaluate this determinant of this 3 by 3 matrix. Okay, so if you see, I will be 0 minus 0 minus j will be also del z by del x will be 0 because these are partial derivatives. So if you are taking partial derivative with respect to x, y and z are assumed to be constants. Okay. Similarly, this will also turn out to be 0, and same thing goes from this also. So therefore, the curl of your vector field f is 0. That means f is curl free. Talking in the language of this question. So f is curl free, not divergence free. So curl free, yeah. So option B has to be correct. D is not correct. Okay, that is also I think same as per your answer key. Yeah. Okay, so very straightforward question. Just supposed to take the curl and divergence of the given vector field. So you should remember what is the formula for curl, divergence, and in some cases scalar also is required. In this case, the scalar is not required. So usually we can take scalar of gradient of a scalar field as well as vector field, but divergence is only for vector fields, and divergence of a vector field is scalar. Curl is also defined for only vector fields, and it is also a vector. So curl of a vector is also vector. Okay, so those are basic things that we have regularly discussed in our regular classes. Okay, so if you have attended those, you should be able to solve these type of questions quite easily. Okay, so now again a probability question. So they are saying 3 dice are thrown. Okay, so there is a similar question that we have solved previously. So 3 dice are shown, but they have not mentioned any colors or anything. So we assume that it is a fair die. Then the probability that no outcomes is similar. Okay, that is given by P by Q. And they're asking what is Q minus P, where P and Q are co-primes. So first thing you should know, what is the meaning of co-prime. This means that the highest common factor between P and Q is 1. Okay, so that means like when you do the factorization of P and Q in terms of prime numbers as a product of prime numbers, only 1 will be common in all of them. Okay, you cannot have 2 and 3 common in P and Q. Okay, for example, let's take P as 4 and Q as 6. So I can write this as 1 into 2 into 2, and this as 1 into 2 into 3. Okay, but here you can see that there is a common factor of 2. Okay, so therefore in this case P and Q are not co-prime. Okay, this is the basic definition. We'll solve the question next. Okay, so let's come back to the question. That what they are saying is the probability that no outcomes is similar. Okay, so first of all, when you are throwing a dice 3 times, so total probabilities or total number of outcomes will be nothing but 6 into 6 into 6. Okay, because when you are throwing a die, in three times, if you throw the die, you will get 6 into 6 into 6 total cases, right? That is 216. Okay, but now what are they asking for this event? What are the favorable outcomes? And the event they are mentioning is no outcomes is similar. Okay, so for example, in the first try, any of the number could turn up. Okay, so there are 6 possibilities in the first try, but in the second try, the number that has turned up for the first try should not be there, must not be there. Okay, so there are only 5 choices. And similarly, in the last try, the numbers that have been turned up in the first couple of trials should not be there. So only there are 4 choices, right? So here, if you look at this, 1, 2, 3, 4, 5, 6, anything can be there. But let's say 1 has turned up in the first try. So for the second try, only available options are 2, 3, 4, 5, 6. Okay, that is why only 5 options are there. And let's say in the second try you get 2. Okay, and therefore for the last third try you only have 4 numbers allowed. Okay, you cannot have 1 or 2 there. Okay, so therefore number of favorable outcomes for this event will be 6 into 5 into 4. Okay, And now we have to take the probability that is favorable by total. So therefore, and that probability is given by P by Q, right? So therefore, you can write P by Q as 6 into 5 into 4 divided by 6 into 6 into 6. Okay, so 166 gets cancelled. Now this is 20 by 36. But they are saying P and Q has to be co-primes. So therefore, 20 and 36, they have 2 as a common factor. So that is not correct. So you have to just reduce this in a next fashion. So 5 by 9. Okay, so you can't go below that. And if you look at this, 5 and 9 are co-primes, right? Because 5 factors are 1 and 5. 9 is 139. So they only have 1 as the common factor. And 1 will be everywhere, right? Because it's a common factor of all the numbers. Therefore, you can say P is 5 and Q is 9. Okay, you can't take P as 20 and Q as 36. That is incorrect. Okay, so that is the importance of this last piece of information where they had mentioned P and Q are co-prime. And what they're asking is Q minus P. So Q minus P will be 9 minus 5, that is just 4. Okay, that is your answer. So if you look at this, yeah, the answer is 4. Okay, so interesting question. They tested your knowledge of probability also. When similar events are not, or similar numbers are not supposed to be turning up in the cumulative die throws. And that is the usual question, but in the end they try to confuse also what is co-prime and all. So basically they are testing your basic knowledge of maths also. Okay, because this co-prime and all, they are not taught in the regular GATE classes. They are your previous year concepts. Okay, and also this was a data entry type of question, so you could not have guessed by options as well. Okay, so it's a good question. So now let's go to the next question. Yeah, and I think this is the last question in this quiz, if I'm not wrong. Yeah. So this is the question from numerical integration topic, and they have given you an integral, which is definite integral 0 to 6, 1 by 1 plus x square dx. Okay, and using Simpson's 1/3 rule, you're supposed to take 6 subintervals. So that makes sense, because for Simpson's 1/3 rule, you have to have even number of subintervals. Okay, for Simpson's 3/8 rule, you have to have subintervals which will be multiples of 3. Okay, so those are pretty important considerations when you're applying those rules. And you're supposed to find the answer correct up to 4 decimal places. Okay, so this question stops here, but in many GATE questions I've seen, because this is integrable directly also, it will be, if I'm not wrong, tan inverse x integration, and then you're supposed to put the limits 0 to 6. So this will be your whatever this tan inverse 6 minus tan inverse of 0 will give you, that will be your exact integration. Simpson's 1/3 rule will give you approximate integration, right? So in many cases they ask you error, relative error, percentage error, all those things, absolute error. Okay, so all those things we have discussed in the classes. They have not asked here, but that is also a very common question. That's what I wanted to try to tell you. And now we'll solve this. So here, typically we consider lower limit as, let's say, a and b. So if you compare this with a comma b, f of x dx, then you'll get a equal to 0, b equal to 6, and your f of x is 1 by 1 plus x square. Okay, and your number of subintervals is 6. They have told you to take this as 6, and the standard formula is b minus a by h. Okay, so h is step size, so this will be 6 by h. So that means h will be 1. So this will be your step size. Step size is important because you're required to evaluate this f of x at all these steps. Okay, then only you can do numerical integration. Okay, so therefore you are supposed to create one table basically. Okay, like this. So these will be your x values, and these will be your f values. Not writing f of x everywhere. Okay, so then you'll have 0, step of 1, 2, 3, 4, 5, and 6. Okay, what will be the value of your function at 0? That will be just 1. Here it will be 1 by 1 plus 1, so it is 1 by 2. Here it will be 1 by 1 plus 4, that will be 1 by 5. And similarly, this will be 1 by 10. This will be 1 by 17, 1 by 26, 1 by 37. Okay, so this is a standard procedure for any numerical integration technique. And now once you have that, the Simpson's formula, that is, Simpson's 1/3 formula, because there is a 3/8 formula also. So since they are asking 1/3 rule, the integration from a to b f of x dx is approximately given as h by 3, which is again your step size. Then your first f of a plus f of b. Okay, so first and last values of your functions multiplied by 4 into f values at odd x. Okay, and plus 2 into, again you have to consider all the f function values, f values. So they will be added basically. Okay, sum of all the f values at even x. Okay, and this odd and even, we are talking about the interval index. Okay, so if you go by that logic, there is a standard formula. I'm not writing it in standard form because that is given in regular classes, and you can look it up also. But the main thing is, for odd function values at odd intervals or odd index intervals, you are supposed to multiply their sum by 4, and for even index, you are supposed to multiply their sum by 2. That is the main thing. Okay, so if you look at this table, so this is your first and last, that is fine. And then this 1, 3, 5, they are your odd f values. I mean f values at odd x intervals or index of intervals. And then this 2 and 4 will be even f values at even x. Okay, so therefore, maybe we can use the next slide. This 0 to 6, 1 by 1 plus x square dx approximately is 1 by 3, because h is 1. First value is 1 and last is 1 by 37. They don't get multiplied by anything. And then you are supposed to multiply the odd ones by 4. Okay, so those will be 1, 3, and 5. So that is 1 by 2, 1 by 10, 1 by 26. Okay. 1 by 2, 1 by 10, 1 by 26, plus 2 into the remaining even ones. Okay. Those will be 1 by 5, 1 by 17. By 17. Okay, and this whole thing is multiplied by 1 by 3. Okay, and now we are supposed to do the calculations, and since they are asking you to find till 4th decimal accuracy, we'll do that. Okay, so this will be 1 by 3, let it be like this. This will be 38 by 37. The first fraction will be like this. Second, okay. So yeah, what we can do, we can let's do it this way, because doing this fraction addition is also a pain. Okay, 1 by 2 plus 1 by 10, that will be 6 by 10. Right, 1 by 2 plus 1 by 10, that will be 6 by 10, that is 3 by 5. Okay, plus 1 by 26 you are supposed to do. So that will be 78. plus 5, that is 83 divided by 26 into 5, 130. Okay, and the last one will be 2 into 17 plus 5, that is 22 divided by 17 into 5, that will be 85. Okay, and now we have to do the simple maths. You can use the calculator after this step also. Okay. Okay, so let's do that, because I don't think we should do the fraction simplification further, not required. Anyway, we are supposed to get the correct answer till 4th decimal place. That is what they're asking in the question, right? So we will take 5 decimal places and we'll see. Okay. So this 38 by 37, that is first fraction, turns out to be, this is 1 by 3, let it be 1.02703 plus 4 into 83 by 130 we have to do, right? 4 into 83 divided by 130, that is 2.5535 384. Okay, 2.55384. Okay, and then 44 by 85, that is 0.51765. Okay, 51764. Okay, and then let me just quickly do it, because this is simple algebra. So 1.02703 plus, I could have given this to you to do, but let's finish it. 384 plus 0.51764. Okay, and then we are supposed to divide by 3. Okay, so therefore this approximate value for this integral turns out to be 1.36617. Okay, and they're asking you to round it off till 4 decimal places, so this will be 3662. Okay, so if you look at the options, 3662, so option B is the correct one. Okay, yeah, that is correct as per your answer key also. So these options were quite close, so you're supposed to carefully do the calculations, don't commit any mistake, otherwise you'll end up with some other option. Okay, I think this was your last question, standard question. In place of Simpson's 1/3, they can ask you Simpson's 3/8, trapezoid, anything they can ask. Okay, and then the next part, as I told you, error, relative error, true error, absolute error, all those things are also possible. Okay, so with that we'll stop and see you next time. Bye.